right.
Oh. You want my store?
Okay, I found a board.
It should be the same link as last time. For streaming?
Did you already send it?
Before. It's a water cream. Oh. Oh my god.
So everyone's getting food, so hold on.
Yeah. Isaac, are these your keychains?
Yes, those are his keychains.
You're so cute. Central. His Skype username's on the back.
Yeah.
No, it's my Instagram.
Oh, his Instagram. Isaac, why did you put this back if it's
Getting food, so hold on.
Isaac, are these your keychains? So you wanna like throw this away?
No, that's a school in here.
I know. Well, obviously not do that, but like after.
That's for you. Here's a Coke. This is for you.
Thank you. Are we live?
But I thought they were testing it.
We are live.
Oh. What? Nani?
Everyone's listening to what
Everybody's
we're
been
saying.
listening.
Hi guys.
So 1 minute.
So we go.
Like, so like we've been on for a minute. Chris, move.
We're going on the air on 1 minute.
I mean,
Oh,
we
we're
are
not
on
live.
the air. We are
We're in
live.
the air, but we're gonna start in 1 minute.
Look, from that little ice cream. Look how fuzzy it got. No.
What did you do to this one?
I put ice cream in it.
That
Wait, let me
is
try some.
the beauty of chemistry right there.
Let me
That
try
is a
mine.
chemical
Please.
masterpiece.
Okay, I'll only let you try it if you pour some of yours in it, or like you,
Okay,
you
yeah,
pour,
Let me
you
see
pour
my money
more.
right.
Huh?
I'll see my monitor.
Okay, hold on. Yeah, I'm trying to get you the link.
Lick it, lick it. You diluted it too far.
Okay, now I'm here.
Okay, napkin.
That's so good.
Can I try it?
Yeah.
No, you can't. Sure.
I literally co-invented this with Amanda.
Yeah, leave us alone.
Who's mineral water for those?
Ah, he did.
Excuse me.
Lick it, lick it. You diluted it too far.
Okay, now I'm here.
Okay, napkin.
I love how.
That's so good.
You know what? Can I try it?
Yeah.
No, you can't. By accident. Yeah.
Wait, Chris,
I literally
here.
co-invented this
This is
with
by accident.
Amanda.
Yeah, leave us alone. Hey, cheers. Take out your
Who's mineral water for those?
Wait, I can't.
Oh, we're co-developers.
Lick it, lick it. You diluted it too far.
It cannot be the same link. Say we're
Yeah.
the same link.
I know. I got it. I got it.
I love how.
Sure,
You know what? Can I try it?
Yeah.
We're going. Going.
You're in.
I literally co-invented this with Amanda.
Yeah, leave us alone. Hey, cheers.
All right, guys.
Take out your
So, Amanda,
Yes.
you're in charge of getting to review
Oh,
the
we're
new link.
co-developers. My laptop closed and it takes forever to start.
Well, whatever it does, you're in charge of that.
Yes, sir.
Chris. Okay.
Hi, Chris.
So we have that. Let me make. So we got 4 people watching.
Already?
Yes.
Hi.
Including.
Well, we're not even.
I'm pretty sure we're watching ourselves, but
Yeah.
I'm not watching me.
I just like put it in front of the room. Like, who cares about the room?
Oh, but the
There you
branding. No, but you can't show branding, dumb.
yeah, we can.
Yeah, we can. We're not telling people to go buy it.
Exactly.
Oh, yeah, don't buy it.
Okay, guys,
Ah.
we going? Are we ready?
Yes.
Where's my napkin?
Oh, was it this napkin? Chris just gave me a napkin.
What do you
Yeah, I
mean?
threw it away. Because it was just wrapped like on the top and it was like in here.
All right. So, welcome back. Today we're in the second episode of the CSS podcast. Last episode we went over basic input and output and integers and floats, and since then Isaac has been doing homework. You were kind of our guinea pig for someone who doesn't know much about CSS.
No, you're the pig too.
I'm not talking about you.
Oh shit!
There's a lot of stuff.
This leads us to our next segment, roasting Chris.
That's the last part of the
The
session.
roast of Chris.
Alright.
Alright, so on this episode of the CSS podcast, we're going to go ahead and move on, and we're going to discuss functions and classes, because those are pretty essential to computer science. First, I just want to make sure that if anybody's watching, I want to make sure that there's no lagging, everybody can hear us.
There's sound, yeah.
There's sound, there's no cutting off. Is everything good?
Let us know in the comments.
Let us know in the comment section, and if there's an issue, we'll go ahead and take a quick side to try to fix it. So, that being said, Isaac,
Yeah.
what are you doing right now in your CS1 class?
So, right now in my CS class, we're discussing variables.
Okay, so that's what we discussed last time when we got the string variable and how we put the data into it.
Yep, but we're also, what is it? I think they're teaching us, right now they're teaching us how to use,
Functions?
functions, yeah. We're learning about manipulator functions to like round and,
Okay, so right now they have you doing like
basically my most recent program, the user has to input a temperature in miles per hour. A velocity in miles per hour. You have to input a time in seconds, and the program tells you the acceleration required to achieve, for example, 60 miles per hour in 5 seconds.
Okay.
And then he said, but also they're teaching us how to make it pretty too. Well, I want to say pretty. Basically, my homework, the last line for the homework, aside from making it tell you the acceleration required, honestly, it needs. Basically, they want you to round it off to 1 decimal point, but display it as 2 decimal points.
Okay, so yeah, right now they're still touching on the display, so the output part of it.
Yeah.
And I remember that's a pretty big part of CS1. It's just getting. Eventually, you're gonna have to start setting tables.
Oh yeah,
and
he's
whatnot.
showing us how to make like columns and stuff like that.
Yeah. So in order to progress a little quicker, we're gonna go ahead and skip over the whole just display of the command prompt, because really, I don't think I've ever used that. Have any of you guys used like the IO manip when you had to get like make tables and stuff on the command prompt?
No.
I've never coded in command prompt ever, never. It's been on Visual Studio's the console application.
Yeah.
Yeah.
That's what I did. But I've heard like experts tell me like, oh yeah, like if you really want to learn C++, you should do it on command prompt. I'm like, but why? Because it helps you. I'm like, how does it help you? Like it's just I'm like,
End the conversation.
yeah, and he slapped me and just walked away.
All right. So because of that, we're gonna go ahead and move forward to functions, because that's kind of the foundation of how you want to set up your program. The more you program, the more you realize that it's better to set up a program with a bunch of little pieces. So good software design is modular. So you make one function to do something, and then you make another function to do something else, and then you keep it going. So if something breaks, the whole program doesn't break. A very specific function breaks, and you know exactly what it was. So that's why knowing how to design your functions and knowing how to set up your program is very important. So today we're going to be using Visual Studio. to go ahead and set up our base program. So just like we did in the first video, let's go ahead and get our project set up. It's going to be project 2, empty project.
You should name it something. Okay, no, I'm into this.
Oh, okay.
I was gonna name it, I don't know, Functions.
Yeah?
Podcast. CSS.
The Functions podcast.
The Function Podcast.
Or, you know, Project 2 is good.
And then let's add our C++ file. Source. Okay, so I guess this is a good time to introduce header files. That's usually where a lot of people like to dump their functions. Have you had any exposure to a header file yet?
No.
That's way too much.
Okay. So first, let's get our Hello World program set up, and then we'll move forward from there. So it was hashtag include
iOS string.
Yes. And
Using namespace STD, not traditional.
yes, and then int main
I'm so sad that we have to explain it.
and return. This generation is eating Tide Pods. I think explanations are mandatory.
God damn it.
Okay, and
What's the part we have to do today?
Did you share it on Facebook or?
Yeah, I put it in the CS3. No, the CS chat.
Read it.
right, there you go. Perfect. Hello world. Someone's phone is ringing.
I agree.
Oh, why do you have to put them on spots?
Oh no, I just heard buzzing. I didn't want you to know.
That's that.
I didn't get my drink. Amanda stole.
You want a drink?
Did you make a float?
Yeah, we got the leftover ice cream and put it in like Coke. You want to try some?
Oh, cool. Okay, thank you very much.
Over the computer.
All right.
Oh, over the $1,000 something?
Cuba. Okay. So let's include our string function so we can manipulate strings. I mean our string library.
Oh, string?
Yeah, so we can manipulate our strings. So now we can use the class string s and make it equal to hello world. And then instead of having to write it out, we can just put s. And then
Should you use the quotations for the string, or should we use the little carrots?
okay,
Or the little thing you wrote
so your question is it this or this? Oh, or that? So
Yeah.
Is it
For
this?
the
we're not talking about this. We're not talking about this. We're not talking about this. We're talking about this. Okay.
that's a
Sing-
SpongeBob reference. I'm not sure you guys.
Single
got it.
quotes versus double quotes. In most programs, most programming language like Java, no, not Java, JavaScript or Python, sometimes it really doesn't matter. But since we're programming in C++, it does. The double quotes means a string, and the single quotes means a character. So character is a single letter, and a string is a string of characters, so multiple letters.
Yeah.
And so yeah, in this case, if you're using, since we're using strings, we're gonna want to go ahead and use the double quotes. Nice catch there, Chris. So for example, if we're making a character C, then we'd use B, right? And now we can do hello world. See. So when we compile this and run it, hello world B. So single quotes is a character, double quotes is a string. So now that we have our file set up, we're going to empty it out.
That's so cool.
And there are two ways to set up functions. You can set up what are called, I think they're called, not constructors, they're the functions that are at the top, and then you populate them at the bottom of the file. The name has escaped me. They're
Prototypes?
prototypes. Thank you. So yeah, you have what's called a prototype, which is a function that you're going to use, but you don't actually program it, right? So let's say you're gonna put in a name and then a gender, right? So this is a throwback to our first program, that like on our test podcast that we did. We're gonna give a name and then either a character F or M, and then the program or the function will spit out Isaac is a boy, or Amanda is a girl, or Isaac is a girl. We don't know.
Isaac's a horse.
Yeah.
Or Isaac is a horse, okay?
Or it's a helicopter, a unicorn.
So
You can't just assume.
we're not assuming, we're programming, okay? So what we want to do is we want to let the compiler know that we're going to use a function. It doesn't need to know what the function does yet. It just needs to know what the function is going to be called. And since the compiler reads from top to bottom, usually your function needs to go on top of your main function, or it needs to be included in the header file, right? So over here on top of the main function, we can do, let's see, we're gonna return a string, right? So we can make a string function, and we're gonna name it what is.
String what?
So we're gonna make a string function, and we're gonna name it what is.
With no parameters?
Yes, we're gonna add two parameters. One is gonna be a string.
What's the parameter?
What?
Yeah, actually, I'll pass it right now.
We didn't talk about that last
it's a parameter.
podcast.
So a parameter is variables that you give a function that the function can manipulate. Okay? So in this function, when we start programming the function, it can grab whatever you feed it and manipulate it as you're programming it. So let me show you a quick example. So we're setting up the function what is, and then we're going to give name and a character, so G for gender. Right? And then we're going to return a string. Okay. So now down here,
That's what you think from the comments?
so down here, we can say what is, and then give in an initial string, so Isaac, and then a character, so B. And what it's going to return, it should be the name, right? So our two parameters for our what is function is Isaac and the character B, right? So these are what we're giving the function to work with. So now, like we said, we wanted this to be a prototype. So we're not going to have a return type here. We're just going to have... No, we don't want to... Yeah, it's okay.
Hey, in case you guys are wondering, the quickest for me.
Our minor. Our little one.
20 and a half, goddammit.
Okay, there you go.
This many.
I'm just kidding, I'm actually 2 years old.
So now we have our prototype. And then down here we can reference that prototype. So what is that? that's the correct syntax. Oh, and we forgot semicolon. Yeah. There you go. Okay. So, assuming we have a single function, right?
Yeah.
This is how it can be set up, right? So return. So at the beginning of the program, we have a string function, and remember, this is just the return type. So this function is going to return a string, and it's going to take in these two parameters. Now we don't have to give it a parameter; it can just be empty, and it just knows, you know, it doesn't need anything to run. But we want to give it a name and a gender, and then I want it to output whether it's a boy or girl, right? So let's just do that back. Okay. So the way I like to think of it is in your main code, when you use this function, replace this with what it's returning. So for example, it's going to return, what we want this to return is name plus is a boy.
Yeah.
Alright? Or girl, depending on the gender. Just to keep it simple. Right? So how would I get this to see out? Right? Well, this statement, I would put it in a see out statement. So what I can do is encapsulate this function in a see out that. And because this is going to be returned here, this essentially means the same thing as writing in Isaac is a boy or girl. Our logic's going to take care of that. These two essentially mean the same thing. Because once you run this function and it returns this, that's the value that's going to go in there. So the compiler would essentially replace this function and put in a value in there. So function doesn't necessarily have to return anything. It can just do something.
Hey, wouldn't there be a space right here?
Yeah, you're right. Because or else it'll be Isaac is all together.
Yeah, no, I myself, Isaac, noticed that. And,
good job.
Yeah.
Good eye.
Very good eye. You're gonna need that eye when you lose a couple of semicolons.
Yeah. No, it was all me. No one in the comments. Just me.
For sure wasn't Xander Puckett.
Oh, it's Tony.
Xander Puckett, fuck that guy.
He's the guy that he's the guy that bought your Isaac is Gay program.
Oh!
There you go. Okay.
Thanks. I don't know.
What?
Thank you.
I don't know why you guys didn't catch on to that.
I need to get a chat going because I don't have any visibility of the chat.
So Xander.
What if this is his fetish? It's like just a bunch of programs where it's just a bunch of like different
Why is he so obsessed with
Isaac
you?
statements.
No. So about 2 weeks ago, Xander Puckett or Tony, right?
Yeah, his well, whatever he likes, whatever he prefers.
He bought a program that we made on a live stream as a test for $30, right? $30.
Yeah.
And
Well, it was a donation. He made a donation, and his request was that we send him the source code.
Donation, yeah.
Which,
And
remember, any of you guys can make by signing up for a Patreon or donating to the link that we have set up for PayPal. We'll go ahead and post that in the comments later on. But I know what you were saying, Isaac. I mean, Chris.
Yeah. So I don't know. I want to thank you, Tony, for buying that program.
You basically bought us pizza
donation.
then, so thank
Yeah,
you.
you did, man. Thank
Yeah,
you.
on the first episode, those I think $42 because Chris also did a handstand and got us $10.
I did.
The handstand?
But
You were there, weren't you?
No, the first one.
I
We're
didn't
gonna post
understand
it in the.
But we totally spent that money in like one place, so we no longer have
Please send more.
So please send more. Yeah, we'll keep doing these videos as long as we get money. So,
Y'all
help,
want to get some pizza tonight?
help por favor. Anyway,
What do you wish I
Anything
was?
helps.
What do you wish I was, Tony? Tell us and we'll make you a program.
Maybe function without timers.
I'll be anything you want.
Hi, Chris.
that's great. Oh, I'm sorry. Let's move out of your way here.
No, this is not touchscreen.
But this is like opening.
Yeah.
Okay. So back to our function. I was saying that a function doesn't necessarily need to return anything. It can just do something. So just like we have a prototype here, and it says it returns a string, it can be void, and that just means it doesn't do anything. So it can make a void function that say hi, right? And we don't need to give it a parameter. But if, like example, we wanted to say hi to Isaac, right? We can give here a string name, and it'll say hi to whatever that name is, right? So we can do just a simple cout hi name, and there you go. It'll do that. So now we can call it and say
Yes,
hi.
please, not over lockups.
And I think let's see, for this time let's add Amanda. So
Hey.
Amanda. Alright, so we can compile this, and when we run it, hi Amanda. Right? It didn't return anything. We didn't put it in a cout something. Since it returns value, you can the what is. We can make a string and make it equal to that function. There you go. We can make it equal to that. So now, whatever our string function returns will be added into this variable, and we can use that variable later. So, for example, now we can do a cout s and line, right? So that's really what's good about functions. It's versatility. It instead of coming back to our code and saying, gee, where did it go wrong? Well, this cout is working fine, but the value s might be wrong. So then we know that really our problem here is inside of this function, and we can go into that function and fix it, right? So to keep up with good programming convention, we have two parameters at top. Oh, great. Okay, there you go. Let's keep two parameters, and
Hey, you fixed your curly brain.
oh, there you go.
Not animals here.
Was that you or someone in the comments who?
No, that's just me.
You're just picky. Okay.
Like alignment.
There you go. Okay, so our function is going to take in a name. So we already have the name, and we're gonna check, right? So there's these things called switch cases or switches, right? And it's essentially just the same thing as when we went over last time, the if statements.
Yeah.
What it does is you give it a parameter or you give it a variable, and then depending on what the value of that variable is, you can have it do something. So right now we have a gender parameter, right? So it's the G. So if it's a B, we want it to say it's a boy, right? If it's a G, we want it to say it's a girl. If it's an H, we want it to say it's a horse. If it's an A, it's an attack helicopter, you know.
Can you call the what is function within the void function?
You can. As long as, you know what? As long as they have prototypes, the compiler will know. So let's try it out. I mean, so call the void inside of the.
Well, yeah, since you're already doing like like the what is as like a high name, could you then call the what is function with
Okay, I see what you mean. So like say hi, and then
No,
name. So
No,
it'll
like in the say hi function, like under that cout, could you put what is and then pass whatever name,
oh, I see what you mean.
gender.
Like see out.
Like can you call a function within another function, even though you're only calling one function in the main?
Yes, you can. You're getting to some very tricky territory because you're like one step away from recursion.
Yeah.
Well,
So calling a function within a function is a thing. So that's definitely doable. But you have to be careful that you're calling a different function, right? Because if you start calling the same function that you're working in inside of itself, then you have this inception thing going on where you have a function call itself inside of itself. And that's called recursion. It's actually very helpful, but it's actually a very difficult concept to learn for the first time.
let's pause it.
Yeah, so
To understand recursion,
I'm just curious.
you must understand recursion.
but yes, you can call a function inside of a function.
Someone got that? Joe?
What?
To understand recursion, you have to understand recursion.
Is that like a Star Trek?
You're not Schwaller. Like I made something was that loud.
Yeah, but I got the joke. Now it's like recursion joke.
Yes, yes.
Okay. So I lost my train of thought. Where were we? Okay, what is? So we're using a switch statement. So we have a switch, and it's very different in every language. So let's just look up the syntax. This is something that you're going to do at home. If you don't remember how the syntax is, you can just Google it. So I forgot how the syntax is for C++ because I've been programming for Tamai for the past 6 months in JavaScript. So let's find out. C++ switch statement. You look at I recommend just anything really, and there it is. Okay. So now I hope I'm like the camera is not like we are not blocking, but as you can see right here, this is our switch statement. Now, so it's going to be switch, and then inside parentheses our variable, which is G, and then we put a curly brace, right? And now it's going to be case, and then the value that you want to check for, right? So if we want to check for boy, we put B, right? And we stop it with a colon, right? Now every case you need to put a break afterwards because that's letting it know if G is a B, you're gonna run whatever code for B here, but when you're done, stop. Or else if you have multiple cases, so for example over here we have case G, it'll do both. If we don't have this break here, it'll go into B, run this code, and then keep going for G, and then break. So we want to make sure that for every case, we have a break.
So it stops the loop.
Exactly. So it stops the switch.
So it
So-
stops the searching, basically. Sort of.
So for B, right,
Just a loop.
well, let's have another string called isa. Alright, I don't know. Variable names are arbitrary, so now we say isa can now be equal to is a boy. Alright? Because you gave it a B. Okay? So now for G, you can have isa equals is a girl. Right?
Chris, can I say this?
We actually
I would like
have
to-
a song request from Oscar.
Fuck that guy.
Whoa.
Wait, so I have a question.
Yes.
Because you're just assigning the value for ISA.
Okay.
When or where do you see that out?
There we go.
Okay. So
Or is that when you just assign it and then once it breaks, you see it out? Or does it happen within the key?
So what we're gonna do is you can create a value inside of this function, but it's only gonna be used inside of this function, right? So you can't expect to use Isa out over here in your main.
No, but like, go back to your case.
Okay?
Where does that see out to the console?
Okay, it's not going to see out to it yet. Remember, this is a string function. So what we want to do is we want to, at the very end, we're gonna return something, right? So we can put another string here and final, right? Oh, final is a reserved word. Fin. Fin, right? And what we want, ideally, is for Finn to be Isaac is a boy or girl, whatever, right? So any parameter you do here, right now you're using Isa, right? The way that what I'm going to do shortly is I'm going to make Finn equal to the name plus Isa, and then return Finn, you know? So we're going to combine all the variables that we're using into one final string variable and then return that. So you're giving me this character, you're giving me this string. Now I'm going to do all the logic, all the work for you in this one function and then return you a simple code. Okay.
Let's trade up.
So we have Isa is a horse, Isa is a girl, Isa is a boy. We're not going to go into checking for capitals. We'll just assume that we're always going to give it lowercase. I'm going to assume.
Finn the human. That's why I put Finn the human.
Okay, so Finn is going to be equal to name plus. Oh god, can we do that in C++? Can we just do regular string addition? Let's find out. Is that? We can! Awesome!
Yeah, I think you can.
Okay, but we need... Isa doesn't have a space, so before Xander tells us, I'm going to put a space here. What? There you go.
You're doing great.
Okay,
Ignore side commentary.
so now we had our Finn that's going to check which cases this is going to be, and then add it with our name that we gave it, and then return it. Right? So let's go up and let's test out this function. Right? So see out what is Isaac.
No.
I think that was sarcasm. Okay.
Hey, you're not pizza.
So let's try B. Let's first write down and tell the computer that Isaac is a boy. Right? So just because that's how I like to format it, let's compile it and see if it works. Okay? So we run it. Look at that. Isaac is a boy. So let's run over what it did, right? So the compiler went in and checked, okay, I have this function, I have this function. I don't know what the functions do yet, but I know I can use them. So then it goes by and says, okay, so this is when it gets used. At this point, it goes back and checks. Alright, so this is what I'm going to start doing. So it's going to start C-outing, it gets ready to prompt, and it says, what is Isaac? Well, I have Isaac, and then the letter B. So it goes into our function and says,
So Isaac's a bitch?
no, Isaac is a boy.
Oh, is he a pretty boy?
I don't know. Is he?
can't assume
I
Isaac.
think we need another parameter for that. But anyway, it grabs the name that you gave it, and then it gets the character that you gave it, right? So it checks. It goes switch G, and then checks what letter is it. We gave it a B, so that goes into B, and then is a boy. So Isa then gets combined with name, and we added a space in between, and then gets returned. Once it gets returned, the value, Isaac is a boy, gets put here and gets printed out. So if you could follow all that, then you've got it. You got the hang of it. If you didn't, we can do another round. So let's try again. With a different command, right? So let's say H, right? Let's go through it one more time. So now we gave it. Let's give it a different name. Let's go with Amanda. Or Chris. We haven't used Chris.
So
Chris is a, and then we haven't used the variable G. Alright? So, as you can tell, you probably already know. So, you know where this is going. You know what the expected output is, right?
Other.
We're trying to say that Chris is a girl. But let's see if it works, right? So, this function is going to go straight into our string function. And it's going to check the variable G. Alright? Variable G is a girl. It's going to set is a to is a girl. And then down here, it's going to combine the name with a space and whatever the result for that is. And then return it. Once it gets returned, it gets printed. So when we build it, look at that. Chris is a girl. Confirmed.
I don't know what to tell you guys.
That wasn't a question, though.
Okay. So, and
Hey,
let's talk about for say
Samuel.
yes sir.
How about we change it up a little bit? You know, go like a bit advanced, a tiny bit advanced. Let's ask the user to put like the name of the person and the classification, or you know.
Or okay, that's
Yeah.
good. That's good. Okay,
Let's ask
so
the user now.
so right here, that's kind of combining what we went over last time. So last time we went over variables and user input, right? So we're gonna have a string that's gonna be n for name, and then we're gonna have a character that's gonna be gen for gender.
Oh,
Okay.
hey, throw something there, but since Xander is asking, you should put your name next. You can down put yours.
Okay, so
Yeah, and it's a woman, right?
okay, so yeah, let's say you put some exotic out there, right? Some exotic gender that no one knows, right?
But
Like, it would say woman.
So like he put W, right? It could be woman, it could be, I don't know, like Wombo. So there is a way to default this switch, right? So let's say whatever you give it, it's not a B, it's not a G, it's not an H. What do you do then? Well, that's when you put default and underscore. Okay? So if it doesn't match any of these cases, it'll automatically go into here and run whatever there, right? So Isa will be is unknown. I totally misspelled that. No. There you go. Right? So let's do this. Okay. So Sergio is a W, like Xander suggested. When we compile this, there you go. Sergio is an unknown, and we have the say hi function down here.
How come
so
you
we're-
can't be a woman, or
I can be whatever I want, Chris. Are you saying that I can't be a woman if I wanted to? It's 2018. Caitlyn Jenner won the Woman of the Year award. Not of this year, but you know,
want to go off on
a
that.
year.
Wait a minute.
I want to go off on that.
So can I pass my class?
Like what? What? What do you mean?
Can I pass CS?
You just
For
do
what?
a program?
With Caitlyn Jenner.
Oh. Well, he said
Let's
not
ask
this
him.
year.
What?
It's
He's like
failing to
tweet.
compile.
Let us think.
Let's do it randomly. Here, build it.
Stefano, what are you doing?
We're getting compile errors, so I'm checking for programs. Let's remove any unnecessary flow. Okay, so another thing to mention is if you don't like prototypes, if you think that's just going to mess you up, you can just put the implementation underneath the main function. So you can implement it in the same place as you declared it. right? So that's what I like to do. So I use this little minus, and it does it great. Let's take a look at that switch stick.
This is like
What is it?
There is no break on the default.
I have a question.
Yes?
You. Oh, I forgot one thing.
There you go. Ah,
Oh,
okay.
what's the
Hold,
default?
hold on. Something just happened to me that was a huge pain to me when I was a freshman. I don't know if you guys remember getting linker errors when you first started with Visual Studio.
No,
Okay.
but
I don't think I've been there.
I always thought that the problem, like, you have to go into the editor and then turn off linkers and everything. And then when I was like a junior at a hackathon, I realized that I left the debug window on right here. And when you try to compile with this hidden in the background, that's when it gives you a linker error. I have a newer version of Visual Studio, so it just said unexpected end of file. So it didn't even give me a linker. It just kept failing, and I couldn't figure out why. Right now you saw me struggling to get it to compile.
Struggling through it.
But I fell into my old trap. You know, I left the debug on, and now it wouldn't compile. So now if I run it again, it still fails to compile. But that was a huge problem when I was in CS1.
Huge.
So always make sure you close the debug window or the output that you're getting. So now that we've covered classes, we've covered functions. Do you guys want to cover, start talking about what a class is?
Yeah.
So, or do you guys think we should go a little more in depth on these?
Yeah, like do it.
Yeah,
do
do
a,
one
do
where
a,
it's user input, because you hard coding
Hey,
everything.
okay. You know, alright, I have a confession.
Whoa.
I struggled with Boolean functions. Those were like, it sounds so easy, right? It's just true or false, right?
Okay.
But I still kind of, it took me a while to understand like some of the rules for functions that the Boolean type. You know what I mean?
Like, give us an example.
No.
So like a okay,
It's
well,
just a simple
like
one.
you said,
Simple
just
one.
a function using Boolean. So just like I said, any function can have any return type, right? So a Boolean is a data type that deals with true and false, right? So you can have a Boolean. Did we use Booleans when we did the Is Isaac Gay program? Because that seems like Is Isaac Gay Boolean true. Like that should have been
I
used.
think it actually does.
Okay, yeah, okay. So bool, I don't know, is Santa real? Maybe.
Real.
No. That's true.
Yeah,
Right, of course.
Yeah, of course.
Everybody knows that.
Everybody knows that.
So you say your Boolean equal to is Santa real, and it's true, right? So now you can it's town. Come on, autofill. I would have been done typing it out by now.
So Roman asked
There you go.
if you can explain
There you go.
pointers.
Next podcast.
Oh god, yes, that's gonna be an entire podcast on its own. Pointers.
Pointers.
They want us to explain pointers. That's getting into CS2 territory, and right now we're in the second podcast in, so we're still staying with CS1. But there definitely will be an entire course over pointers and sorting and linked lists and all that. So stay tuned. If you're having issues with your homework with that would be a very good time to go visit our Patreon page so we can specifically cater to your problem. Anyway, we were going over the Boolean, right? It's good to note that when you see out a Boolean, if it's true, you get a 1, and if it's false, you get a 0. So we have, is Santa real? True, right? But we had another Boolean that was, I don't know, is Isaac a good boy? and we set that to false.
Nah.
My dog? You may as well make me a dog.
Is Isaac a good boy?
Okay,
If you
What's
die,
a good
you
boy
do the best
function?
boy.
I'm straight up like
Good boy. And then the
I should get a medal for
Who's a
this
good boy
restraint.
function? Do it. Do it. Do it. Do it. Do it.
okay, anyway, for demonstration purposes,
How come you're using Isaac? Put Chris. Oh, you put Santa.
it did present out here. Let's.
But that's true regardless. How is that in question?
Yeah.
I don't know, what's something that's false?
Just test that.
I don't know, Tooth Fairy.
Yeah, for sure. I mean, I don't know, dude. Like, it makes no sense for a fairy. I don't know, wings, you know, body like that.
What?
Have you not seen pictures of the tooth fairy?
Oh. Okay.
What Tooth Fairy are you watching?
The red tooth doesn't count as a source of information.
Is how many?
Please be quiet.
I'm gonna just
Oh,
go
yeah.
under
We
the
don't
table
need this right
forever.
now. Look, Isaac, we have another Isaac.
Hello, Isaac.
Tooth Fairy. There you go.
He's not the real Isaac.
Oh,
I don't know, you're Isaac Martinez 03.
dope.
We-
If you have
You're Isaac Martinez 01 and 02. Please meet me.
I just want to talk.
Crack knuckles.
God, here we go again. I left it open again, and it wouldn't want to compile. Try this again. There you go. Now it compiles. Jesus. So remember, always close your output windows.
You press enter, you know, at the end of console.
There you go.
Tells you.
It says press any key, you know, but no, you move your mouse. And
No,
to the
I
side.
leave it open so I can demonstrate, and then I'm like, you know
No.
what? I need to type something
No,
else, and I
you
leave it in the
close it.
background.
No.
You know what? When it's 3 a.m. and you're coding for Schweller, I'd like to see you remember your your command prompt window in the background. When you have Netflix, Hulu, and YouTube open for something, because you're like looking up videos on YouTube, and then your show finished on Netflix, so now you're looking for something else to watch on Hulu.
I feel like you put salt and lemon like in an old like wound.
Me or him?
Yeah.
Schweller and Wiley were very difficult times for me, okay?
He's crying a little.
And I had a lot of monitors, so...
Do we need to
Let's
go on
stop the
standby so
stream
you
for a
can
little
wipe
bit.
away your tears?
Anyway,
He needs a drink.
as you can see, we printed out a 1 and a 0. So 2 Visual Studio, a Boolean, or in C++, a Boolean can be either a 0 or a 1. True or false. Now, you guys want to do a function where we get user input, okay? Well, let's do that. Let's do the string.
I feel like we just need to put
What kind of function can we do that gets user
He's
input?
like 5. What was your question, Seth? I'm so sorry.
Okay, we need a function that takes user input,
Yeah.
and we're going to declare the function outside of the main function, and then run it in the main. So just, anything. I drew a blank, so I can't think of anything. What do you guys got?
Let's test.
Does it have to be a Boolean value?
No, it can be any value. I mean, if you want me to use booleans, I can. But you know what? Let's use a boolean value. Okay, so
Yeah, 'cause
it's
that's
going to
what we have
return.
problems with.
Let's a boolean function. So it's boolean function name. I don't know what the name is going to be, and I don't know what parameters you're going to give me. But it's going to return.
Let's do an odd tester. If it's odd,
Okay, that's okay.
it's
So
true. And if it's true,
Even, it's false.
you make it even.
so is odd or is even? Choose one. Are we testing to
It's
see?
odd.
Is odd. Okay. So
Yeah.
we're gonna give it an integer, right? So we're gonna give it an integer x, and this function is gonna determine whether the integer is odd. So what does it mean to be odd?
Chris, I feel like you can answer that
Yes, I
question.
can. Yes, I can. So basically, you use this operator called Modular Operator, correct?
Yes, the modulus.
Yes. Okay, basically, it's simple if statement. If number is modular of 2, which basically means if you divide it by 2, if it has a remainder of 1, then it's odd. If it doesn't have a remainder of 1, if it's 0, then it's even number because you know it was divided in half and it had no.
Wait a minute.
No remainder.
So could odd? Think about it. To be odd means.
You man, you're odd, okay?
No.
You have a 1.
Hear me
God.
out. To be odd means that you are on. To be odd means that you are on.
No.
To be even means that you are off, because to be odd is because 1 is an odd number and therefore 1 means on.
You're trying to incorporate binary, aren't you?
Yes, and so therefore 0 is an even number.
Is it?
Is it? I think it
that's
is.
always debatable, though.
Well,
No, I don't think that's debatable.
Why not?
I thought 0 was always just like a
0 has no number. Like
No, like
it's nothing.
I don't.
It's a concept.
No, that's not debatable.
think about it. Yes, it is.
Yes, it is.
No, it's
Because
not.
look, it's from 2
zero's
to get from 2 to
It's
4.
like the water is
To get
dead.
hold up. To get from 2 before you look anything up to prove me wrong. For fuck's sake, let me have a
Hey.
moment.
I will use the power of Google.
Okay, think about it. Look, to get from 1 to 3, right? Okay,
Okay.
no. To get from 2 to 4,
Okay.
it's 2, right?
Yeah.
Yes.
So therefore, that's basically what even numbers are, right? They go up by 2, right? They do go up by 2, right?
Okay. Yes. That,
Yes.
that is a property
So
of even numbers.
from 2 to 0, it's also 2. So why would -2 be even, and why would 2 be even but not 0 be even?
Because 0 has no number, dude.
Okay. So before I look it up, then we have to define what is it, what it means to be odd. Like I started. So does odd mean you can divide it by 0 and or divide by 2 and have no remainder? Is that what odd means?
A odd number, yeah. Like a.
Because if you divide 0 by 2,
Do we have to have 1?
Yeah.
Do we even have to have
oh sorry, yeah, sorry. So to be even,
Wait,
sorry.
to be odd, it can't be divisible by 2.
No, to be odd, you have to have a remainder of 1 when you divide by 2.
Yeah.
Okay.
Okay?
Okay.
So if you get 0 and you divide it by 2, your remainder is going to be 0. Because 0 divided by 2 is 0. Your remainder is not 1, therefore it's not odd, so it has to be even. So now let's find out. Oh Google. No, you know what? I'm even going
Write
to go.
that. Oh, Google.
I'm even going to go into the Google website.
Oh, Google.
Oh shit, he's busting out the Google website.
0 is 0. No, hold on.
Are you gonna spell out 0?
Oh, is water wet? Number 1.
No!
Number 1 is
No,
water
don't go
wet.
there.
Go to hell.
Okay, let's not go there.
I'm not ready.
That's a different podcast.
Is 0 an even number? Or odd number? I'll leave it open
An
to
even or odd
speculation.
number.
0 is an even number.
What?
There you go.
Take 2 shots. Well,
Okay.
I got it.
Alright, so then,
Good job, Isaac.
back to our program. Now that we've defined odd, right? So, odd means that a number x divided by 2, so x over 2, will have a remainder of 1. So in C++ and in programming, we have this nifty little operator, and it's called the Modulus Operator, and it'll actually give you the remainder. So if you divide 3 by 2, you'll get the remainder of 1. If you divide 9 by 10, you'll get a remainder of 9 because you don't have enough to make 10. So that's what we're going to use here. If we have the integer x, and we modulus it by 2, right? and if that is equal to 0, it is even. If it is equal to 1, it is odd, and our stream is stopped.
Oh no. Our stream stopped. I'm
Well-
sorry for these technical difficulties.
It got me right when I was saying
Hold on, is it just your computer though?
No, mine too.
No, it's his computer.
Card disconnected. Please wait while we try to reconnect you. Unable to reconnect.
Look. Fine.
Oh, that cracked me.
Oh no, it doesn't happen right now. I did this and I did.
Oh no, mine's working.
Yeah, yeah.
Okay, cool.
Yeah, we're good. Sorry.
It's just you, I think.
Sorry, I agree.
It's always you.
It's always weird.
Okay, so this modulus operator gives us the remainder. So whatever this equals is the remainder. So if, let's go ahead and use our handy dandy if statement. If x modulus 2 is 1, that means that when you divided x by 2, you got a remainder of 1. That means it is odd. So we want to return true. We don't even need this there. And if it's not odd, then it's safe to say that it is even. So return false. Okay? So we don't need this. Okay. So let's compile it real quick, make sure we have no errors. Succeeded. So let's go over here and let's do user input, right? So we have an integer input and we're gonna have a cn input. Oh, it's the other way. There you go. Input. And so if is odd, and then what was it? Input. Okay. So this, if this is true, so that means if input is odd, then we're gonna see out our input is odd. Otherwise, our input is even. There we go. Alright, so let's try it out. Let's make sure everything compiles nice and pretty. Everything's compiling. Let's run it. Give me a number.
21.
What's 21?
Why is 21 funny?
It was a Vine video, like from a long time ago. Have you not seen that video?
Yes, I know which one you're talking about.
I wouldn't know what 21 is.
What's 9 plus 10? It's 21. Yeah. What?
21.
Oh yeah.
Okay. So 21. We inputted and 21 is odd. Okay.
You missed. Wait. You didn't.
Oh, do you want me
Wait,
to?
no, open it. No, open it up again. Because you didn't type in 21 correctly. It's 20 and then hun. 21.
Go home.
He is
home.
right there.
20.
Well, go to your room.
Oh, okay.
21.
So 21. Enter. It's odd. Okay.
But
So.
I said, which one?
Which one? The only one. What's 9 plus 10?
Hi, Michael.
Hello, Michael. Oh,
What's 9 plus 10?
there is no Michael here. There you go. Please input an integer. Now let's try an even number. 22. I don't know about you, but I'm feeling 22.
God damn it.
And 22
Oh.
Yes.
is even.
It's good. It's
So
good.
there you
I'm
go.
supposed to acknowledge that.
We have a user input function that uses logic inside our main function to tell us whether an integer is even or odd. Using these same methods, you can pretty much do anything you want. So I know earlier in the last podcast when we were finishing up, we did a what's it called? A Celsius to Fahrenheit. So that's sort of like you could actually just put that into a function, Celsius to Fahrenheit, give it a number, take care of all that junk inside of the function, and then just call Celsius to Fahrenheit over here, and it'll return the number for you. So that's the what's it, the handiness, the helpfulness of functions. It organizes your code.
Let's make a new function. If I'm good with you. Yeah.
Okay.
Hey, but did you understand the Boolean function?
I did now. I already did. True, false.
So let's clean up our code.
Just unplug mine more.
Let's do a new function. Let's look. Let's see some. Think about some on my head. Annoying.
So what kind of function do you guys want to make now? We got user input. We got the function outside. We use the prototypes. I mean, we use the string. We went over void.
Why don't you ask the audience? Gives you a chance to check in on the chat and interact with them there.
Alright guys, what kind of function would you guys like to see? Remember, Xander, this is a CS1 level podcast.
Type it in the comments.
So let me type that because of the minute lag. That sounds like a Twitter poll. If we had like enough followers, we could probably get away with that. Can I have some rum while they decide what kind of function we need? I need some rum and some Coke.
I got you. I we do. You can't touch that.
I can do whatever.
Stop drinking it.
Okay, the screen get like bucks. I want to mess it up.
Why? You can easily replace it.
I need a Coke.
I got you, baby.
It is.
It is.
Hi.
Una Coca, por favor.
I'm on in front of the camera. I'm so sorry.
We have 30 minutes left.
Okay, that's what.
Hey, can we?
Alright guys, we have 30 minutes left, so...
At the end of each one, at the end of each podcast, can we do one question where we kind of like debate the way me and Amanda and you do?
You want to introduce them to your data turns into heat
Yes.
theory?
Oh, sweetie, no.
Please?
No,
I'm not ready.
No, sweetie.
I am willing to...
No. For your safety. No.
I am ready speaker.
I really don't want to do a factorial function. Just because it's so much work and they're not going to see that in CS1. At least not here.
Next suggestion.
How about do a function that will?
Okay, that seems simple.
How about a function that will count every comma in a sentence?
Okay, so are these count every comma in a sentence?
And it will return every comma, like, oh yeah, there was 5 commas here.
Well, but hold
Why
on.
not commas? Why don't you do
Hold on.
days?
We already got a suggestion. It says, well, we could do the loops. I mean,
Read it.
it says the sum of consecutive integers. So it's just
Oh, okay, so
Add-
1 to 5.
yeah. So is it like from 1 to like you give me one number from like 1 to 5, and then I count 1 plus 2 plus 3 plus 4 plus 5. Or is it like I have this many numbers in an array, and then I'm just gonna add them? Keep it simple. Remember, it's CS1. Now we wait for the lag.
So kind of
Dun 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 dun.
Why don't we have that on standby?
I'm so confused.
arrays start at 0.
Yes, I think they do.
I'm so proud of you, Anthony.
Psych, they start at 1.
Okay, so
Take your strawberry milk, please.
so I know one of the labs that I had to do was that I was a teacher and he was inputting grades, and he needed to get like the average of the class, right? So he put input grade, input grade, input grade, input grade, and then put a -1 when he was done. Right? So we can do that. So give me a number, enter, give me a number, enter, give me a number, enter, give me a number and enter. And as you're giving me numbers until I receive a -1, then it'll show you the sum of all the numbers.
Until you receive a -1.
Negative.
Yeah.
Standard 20 self.
Like sum of 3a equals 3 plus 4.
Oh
5
yeah.
plus 6 plus 7 plus 8.
Okay.
I did that before.
Congratulations.
Okay, so int sum.
Don't talk.
Sum.
Oops me.
I booked you, yeah.
Sum int a
I did the wrong
int
way.
b.
Yes, you're wrong.
Okay,
But-
so
Red camera.
for the sake of time, I'm gonna assume that A and B, A is always going to be larger than B. I mean, B is always going to be larger than A. Okay. So obviously we're gonna need a for loop. And Isaac, have you seen loops yet?
No, not yet.
Okay, so this is a good way to get you started.
But I'll be that cool kid. Who's ahead. Hey!
Guys, I heard that.
A, mandatory podcast selfie. Then B, I plus plus. Okay, so there you go. So we have a loop that, right? So we have a for loop, right? So it's supposed to be saying like for every I, as long as I is less than B, then add and do this thing and then add 1, right? So first you set an incrementing variable, which a lot of the times is I, and we're gonna set it to start at 8. So like you said, 3, 8, right? So it's gonna start at 3, and then it's gonna cycle its way up until it hits B. Once it hits B, it's gonna stop and give us our sum, right? So we have an integer named total, and it's gonna start at 0, right? So we're gonna get total plus equals 0. Plus equals I. So that means every time this loop iterates, it's gonna get the value of A and then add it to total. And then, so if it starts out at 3, it's gonna get 3 plus 0, 3. 3 plus 4. 3 plus 4, guys? Come on.
Wait, what?
6.
There you go.
I got it first.
I did it first.
Then 6 plus 5.
13.
11! 15!
There you go.
11.
11.
God.
Alright. And it's gonna keep going until it hits B. Okay? So, and then it's gonna return total. Okay? So, you have to be careful with loops because it's gonna stop when I is less than B. So that means it's never actually gonna hit B unless you tell it less than or equal to, actually equal to B. So that means if I is equal to B,
It's gonna stop.
exactly. So now let's use this function in our main.
Hey. Sorry, something there. Should we do a catcher? Like an error catcher?
Like try catch?
Yes. What if A is actually bigger than B?
No. That's what I said. When I went in here, I assumed that B is always going to be bigger than A. and it's always going to be an integer, so it's not going to be a double. It's not going to be a float. It's not going to be a decimal. So just for CS1 purposes, B is always going to be bigger than A. So you're always going to be able to iterate up to it. So we're going to do int A, comma B. Now we're going to do cout, and we're going to ask for the first digit. First digit. And 1. And then cin. A. Cout. Second digit. I do not want to end line. That's gonna make the UI very weird. Okay. Okay. And then cout sum A, comma B. And there should not be a semicolon there. Sum from A to B is
Sum is equal to
oh, okay, because
sum of the digit.
it's string. Oh, well.
No, yeah.
It's because it's string, integer,
plus.
string, integer, string, integer. So let's do this.
Wait, no, dude, it's not plus.
Yeah, because you can't add an integer to a string. So
It's a little thing. Little.
because in JavaScript you can do that. JavaScript is a nice language. Okay, there you go.
Do you work with JavaScript?
I have.
There you go.
Yeah.
Okay, so first digit 1, second digit 2. What's the sum from 1 to 2?
3.
Are you sure?
1.
1 to 2.
Yeah, from 1 to 2. So 1 plus 2.
It's 1.
3.
That's right.
I know.
Is that 1 plus 2?
We're verifying the
I thought you
function.
meant to
I'm
get
not
from 1
testing
to
your
2.
intelligence.
Is that?
So let's try something bigger.
Wait, what's it?
1
2?
to 5?
What do you mean that was so?
15.
Mike Illuminati just secret where you are.
It's like the FBI.
1
It's like, hey, man, I
to
feel
100.
Like
50-50. Is that even right?
Wait,
What?
I mean, I can verify 1 to 2, right?
1
to
to
100.
1 through 8. No, what it was.
1 to 100 is 50-50.
Do 3 through 8.
Apparently.
Do
5,050 or
50.
50-50?
Well,
I think it's going off by one number, but maybe
it's 5,050.
Maybe because of a 0.
But I set it to start. But I don't know, this could be right. I just don't know off the top of my head what all the sum is from 1 plus 2 plus 3 plus 4 plus 5 all the way up to
It
100.
actually could.
What one?
Some from 1 to 2.
Maybe 60.
It is.
And then just round
Is it 5,050?
Yeah.
Yeah.
Hey, there you go. So we have our working function.
Cool, man.
Thank you, Sanders, for the input.
Well,
So-
he said 3 through 8, but of course.
Oh, okay, you know what? Fine. I mean, that's the beauty of this. I don't have to retype it every single time. 3 to 8. 33.
Is that what we got?
Is that correct?
As you said.
Gotta stay hydrated with my alcohol.
Then alcohol just makes you worse.
You know, I coded my phases 1 through 4 with a 6-pack of Dos Equis for the nerves, for the tension. We have a pledge from Xander onto our Patreon account. I just got the email notification.
Aw, you're too kind, man.
She has pledged $15.79 Thank you very much. Yeah.
What?
That's very.
It's just I don't have we
interesting.
don't have set up like the normal streamers that like every time that they make a donation it like shows their name and their donation. I'd like to have that at some point. We'll be like the PewDiePie of C++.
Okay, sure.
PewDie++. Okay, Isaac. So
Can we do it?
We've reached the end of functions. So the next podcast is going to go over classes and file IO. All right.
Oh, not files.
Yeah. So we're going to have to teach him how to use files and how to interact.
Oh!
So we'll go ahead and reach onto that. So if you guys are having issues with input-output of files, if you guys are having issues with figuring out how classes work, go ahead and tune in next time. And make sure to check out our Patreon page, and we'll automatically go to your homework response or whatever you need help in first. Check out the levels, and depending on how much you pledge, there's levels of rewards that you guys can have, and we'll help you guys out here during either live with the podcast, or we'll reach out to you. But definitely support us, that way we can keep this podcast running. That being said, thank you for joining us for the second episode of the C++ podcast. And from here till close, which should be around 10:30, I believe.
Yeah.
We have a new segment where we discuss
We're doing that?
CS topics.
No.
Yes, and Isaac had an interesting theory he wanted to share with everyone.
No.
And it's interesting.
And that for me too, hearing this. I was like,
So in the words of Brett and
so
Link,
let's start off.
let's talk about that.
Okay. So,
Oh wait.
FY next Wednesday is Valentine's Day. Oh wow, sent from Kimberly. She's like, what do you mean the next episode?
What?
It's fucking
When
Valentine's Day.
We might have to pre-record the podcast. We'll see. I'll pre-shout out happy birthday to Kimberly's brother, his birthday is on Valentine's Day.
Hey, Xander says if he donates enough, can you get him a job?
If he,
It literally says, can you get me a job?
We can.
I mean,
No promises.
how does freelance pro bono programmer sound like?
With no pay.
That's
or
your job.
benefits.
It's still a job.
It's freelance. Any profit that comes in, we can split. You know,
Win-win.
Win-win.
I say it's a
You'll have to
win-win.
sign an NDA.
Yeah. So, we'll contact you. All right. So Isaac,
No.
let's go over.
We're gonna get sad really fast.
So you guys don't know, he's
Why?
a chemist. That's his major.
They like
So
chemistry.
he
Yes.
talks about-
Okay. So disclaimer. Isaac is not a computer science major. He is a chemistry major. So he's looking at
I study energy.
you study energy and the transfer of energy. So that's a good segue into your theory. Isaac, take it away.
Oh, wait, hold on. I need a drink.
Yeah, we need a drink.
Refill?
Just-
Refill? What's the refill?
Before I
What if-
start talking.
What
No!
if I am correct
No!
in chemistry and you guys are wrong, but in computer science I am wrong and you guys are right?
No, because you're trying to enter our territory.
Is it okay with you, son?
Sure.
Just a little tiny bit.
Oh, I see. Okay. I was like, is that all I'm getting? Ooh, thank
A
you.
lot.
That's fine. That's nothing. Can we have a Coke?
I gotta burn this now.
Okay, hold on, Isaac. Hold
Hey,
that thought.
you dropped alcohol.
Hey, don't
the
step on your
blender.
laptop twice.
Okay, well, here.
Well, start introducing the idea. What
Okay,
we
go ahead.
Okay.
Introduce it.
Oh,
So,
I didn't get to say
basically, I have this theory about what happens when you delete information. Go to hell, both of you.
that. We'll see you
So,
there.
basically,
I
my theory is that when you delete something, it gets converted. That data, the information you just deleted, gets converted into heat, and then it's dissipated through the vents on your computer out into the environment. And the reason behind my
The reason.
So the reason behind your thinking?
Carry on,
Did you
carry
do
on.
that?
Behind my thinking, the
Carry
reason
on.
behind my thinking is because everything is energy, including the information inside of a computer. Because it's that information is transferred using electricity, and
So-
therefore electrons, and therefore, according to the first law of thermodynamics, energy cannot be created or destroyed. So if the information itself is made of energy, when you delete the information from your computer and it's no longer using up space in your computer, matter, it must have been transferred to something else and moved somewhere else.
Okay, so in summary, you're proposing that when you delete a computer file or any sort of information, it is then transferred into heat, which gets exhausted by your computer port.
Yes.
That's interesting.
Does your computer not run off electricity? Electrons?
It does.
And the information and all the commands you use, all the information that gets, how do I say this, I guess, input into your computer and stored on your computer, is it not made out of electrons?
Yes.
Electricity can carry information, can it?
Well, yeah.
Therefore, your information, your data is actually energy. It's made of energy.
But my problem here is the way computers works is they have bits, right?
Okay.
So that means that the number 3, right? It's 1100. That means that the first 2 bits have energy, and the last 2 bits don't have energy, right? But if you have 1, 1, and then zeros in the middle, right? Using the same amount of energy, right? Now you have the number 9, right? Which is 8 plus 1, 9. You have the number 9 using the same amount of energy as before, right? But you can overwrite a file. You never really delete anything. So what you do is in the number 3 you have 1100.
And the ones have energy, the zeros don't?
Yeah.
Exactly. So when you delete this 1, you're really just telling the computer you may now use this. So now if it's gonna say the number 9, right? It's gonna leave this 1 as it scans. It's gonna change this to a 0, leave this as a 0, and then add another 1, so it now has 1001, right? But it's still using the same one as before. So it's still using the same amount of energy. No energy was lost, it was rearranged. And the file wasn't deleted. It was written on top of?
Wait. So, yes. But maybe if you change a file, it uses energy. Right?
It does use energy.
Yeah.
But
Because
no machine is 100% efficient. So some energy is always going to be lost.
That's why
to
heat
heat.
comes up.
Exactly.
And also because heat. I mean,
Like there's heat dissipation, yes. Trust me, I play PUBG and my room gets very hot. So yes, there is heat dissipation. But if we stay to like a single like adder function, you're still using 1 1 and 2 zeros, right? The amount of energy before and after is the same. You deleted the number 1 and changed it to a 9, but no energy was lost. The only
Because that energy was used to make another number?
The energy was used to keep the bits open. So you have a register in your computer that is constantly on, right? So you're constantly using 5 volts or whatever volts to keep it on, right? When you change it, right, you're changing the state of it. You're not using any more or any less electricity. You're simply redirecting the flow so that the registers are now different. So if you're using 5 volts of electricity before you delete a file, right? you're still going to constantly use 5 volts of electricity to change it. The electricity is the same, it's constant. All you're doing is redirecting the flow of that electricity. So you're not really changing information into heat. It's more the heat already gets dissipated regardless. But information is like in its own separate chamber because it's the flow of that energy.
So basically, one thing you said though, you said that you basically build over old information. Basically.
Yes.
You create new information on top of old information.
Well, it's not on top of, it's with the old. So
with the old. So it recycles the old to make new information.
Yes.
That's what you're saying.
Yes, because you're using the same area on your hard drive that was your high school report on Shakespeare can now be, PUBG or BioShock or some other game. But you never deleted it. It's still the same piece of hard drive. The ones and zeros just got rearranged.
You're already serious about that?
So it's not really turning data into heat. More like heat is being dissipated anyway.
Of course. I'm not saying that all the heat coming out of your computer is coming from deleted information. Because most of that is just from, like I said, no machine is 100% efficient. Therefore, the electricity that's used to keep it on is going to be dissipated. I'm just saying a part of that energy, a part of that heat that's coming out is probably coming from the information. No matter how small of a bit or a percentage of that heat that's coming out, it's still coming from the information.
Okay. I see your theory and raise you this, okay? What if instead of, the heat that you're saying gets transferred from information to heat, right? Instead of having that, that heat that you're saying is information being converted to heat is actually the processor working to change the data.
Yeah, that's true.
So, let's say if you're not changing anything, you're not deleting anything, right? You have, 20 joules of energy that's being used, right? But if you change this 5 to an 8, all of a sudden that 20 joules turns into 25. And then back to 20 again. Because you change data, and now you're not changing data, right? So that means there was a spike in energy because you performed an operation.
So you went from 20 to 25, and then back to 20. What happened to the 5?
Okay, so that 5 was the CPU using energy to rearrange itself, basically, to rearrange its flow of data, right? So indirectly, you are causing more heat, but it's not the data itself.
It's a transfer.
It's
transfer.
the work that the processor does to change that, right?
It's a usage of your CPU.
So if I get sweaty, it's not because the box that I lifted turned into sweat. It's because I lifted a box.
Make you feel so retarded.
It's because I lifted. It's because I lifted a box, which made me sweat.
That's because the energy inside of you that was used to
exactly, because he worked
manifest
to get the box up, and now he's sweating because of it. Yeah.
But the box didn't.
There was, look, when you use
5 minutes.
1 minute?
5 minutes.
Oh, 5 minutes. Okay.
So energy is required to lift the box, right?
Yes.
However, once you actually start moving,
That's
organic chemistry? No, that's not. That's
Okay.
general chemistry kinetics.
okay.
So basically, but once you start moving, right? Any motion at all is kinetic energy.
Mm-hmm.
That's why when you run, you have a bunch of kinetic energy.
Yeah, it's conservation of
Yes.
energy.
Yes.
So that's why your body is now, this flow of energy is now moving into your,
Okay.
and therefore your body is trying to dissipate. Fuck off, guys.
But what you're saying is the equivalent of if I lift up this box
I'm not saying the box is turning into sweat.
No,
You're
but
saying
like, the workload to pick up the box is making you sweat. But no, yes.
Like if I delete this box turns into energy. And Einstein says that's correct.
But heat.
Because you better have the creator to destroy, right? It can only be rearranged.
Yeah.
What you're saying is, if this box that I'm lifting is a file in a computer, right? When I delete it, it turns into heat. Poof, right? What I'm telling you is, it's not necessarily that I'm deleting the box, right? It's that instead of getting a box, I'm going to turn it into, I'm going to flatten it out and I turn it into, I don't know, a cup. And now it's no longer a box, now it's a cup.
Yeah.
And I can drink water out of it, or I can make it into something.
Yeah.
The matter in the cardboard box stays the same, but the amount of effort that I put to change the box from a box to a cup, that's what the increase in heat is.
Okay, I see what you're saying. But I can explain it. I can explain it.
I think the people who start like sending some opinions about
The box is the
You know what, guys? Be honest about my. Well, can you type it? Since you're the one.
Yeah.
I mean,
They have like the little crap.
Express your opinions on Isaac's theory.
Isaac's theory.
But basically, look.
2 minutes. You can start like wrapping up, guys.
Okay. I see what you're saying, and you know what? You're absolutely right, Sergio. So there you go.
He's so mad about it. Relax.
We still have some time. We still have like 2 minutes.
We appreciate your theory.
So let's see what they think, okay?
Look. It's different on a CPU. Like suppose that it's completely different on a CPU. Like it's different from like
How's it
a
different?
CPU.
How is energy?
Okay, no. It's not it's not the fact that I'm deleting this cup in a virtual world, right? Like in my CPU. It's a CPU, right? And I delete this cup. It's not really gone. Like I just make this now into bits that I can use to add more files. And if you add a file, like all I'm doing is I'm like just rearranging the bits on that file. So the CPU could grab those bits from this cup or from the cup that was a cup and like make that file.
Okay, I understand that now. No, I'm agreeing with you now.
Yeah.
No, because now I agree with you guys because I just had a revelation in my mind. So basically,
okay, hold on. You had a revelation in your mind, or we explained it to you and now you understand it?
You explained to me, but I can explain your explanation through a chemical reaction.
Well, what you were saying kind of makes sense. You know, like you made me think about infrared transfer of data.
There's even Wi-Fi can be like.
I mean, when you send a file or when you print a Wi-Fi or anything like that, it goes through space. It has to turn into energy and then turns back into the computer.
Is Wi-Fi energy?
So you might be onto something.
Wi-Fi is energy, yes. It's radio waves, which are by definition electromagnetic waves.
I haven't seen one. I really don't know how it works. But basically, they were flashing some kind of like flashlight thing, and it was like kind of like a strobe.
It's called binary, my dude.
But yeah, it was like sending.
When light is 1, light is 0. But anyway, we've run out of time. We've
run
out of time, folks. Tune in next Wednesday for what was it, classes and files, and we'll come up with another theory or another topic to talk about. Check out our Patreon page, and if you like what we're doing, go ahead and help us out and support us so we can get better lighting, better equipment, and make it better for you guys.
I'll also have a new question every single time to present to you guys at the end.
We won't be live streamed next week though, due to the holidays, so it will be pre-recorded.
Love in the air.
As long as they really hold.
You don't have to think of production.
Do you want to fight Kim?
Look, Isaac, I have someone to see, okay? Sorry, you're just...
What are you talking about? We're doing
Oh my
this
god.
Alright, guys.
Chris.
Thank you very much for stopping by. We'll see you again next week.
Thank you for
Have a great week, guys.
Adios.
Keep coding.
Bye.